Okay, section 2.3. We're going to look at these 1 through 6 and match it with the bottom part. Um, so when we're looking at them, the intersection of A and B, that must be, it's all elements in A are also in B. So that's going to be, they're common to both. So B right there, the sets of elements common to both A and B. The union basically means one of everything's included. So you want to include everything that's in each of the sets. So when we're reading through our choices, that one's going to be the F, the set of elements that are in, the set of ordered pairs such that the first element, wait a minute, what is that? That says F, that are in A or both in A and B, so F. So what happens when you have a union is you want to include one of everything. So you look at the elements in A and you include them. You look at the elements that are in B and you include them, or if they're in both A or B. So for part number 3, the difference of A and B is going to be, you take everything that's in A that's not in B. Complement. So if you know what A is, the complement is everything that's not A. So the wording for that is the set of elements in the universal set that are not in A. 5 is the Cartesian product of A and B. That's, remember we talked about that. That's kind of like the distribute. You take every element. It's an ordered pair, and where you take every element in A and pair it with each of the elements in B. And then you keep doing that until you have the Cartesian product. So that one's going to be E. And then the difference of B and A. So that's if you take all the elements that are B that are not in A. So subtract out the A terms, A elements. Okay? And this will be easier to determine whenever you're able to see some of the visuals. So our next task is we're giving a universal set. Okay, so they tell us what the universe is, and then they also tell us some other descriptions. We know what set X, set Y, and set Z are composed of. And then we're going to do these calculations over here. So we want X intersection Y. So we want all the elements that are in X and in Y. Okay, so which ones are those going to be? In X and in Y. A and C, looks like A and C. Okay, union, that means everything that's in X is included. So X was A, C, E, G. Okay, and everything that was in Y. Well, we already used A and C, so what's the only other thing we need to include there? B. All right, so try 9, 10, and 13. And if you'd like to, you can try the complement, X complement. That one should be pretty easy to you. Okay, so let's look at what we got for y union z. So y union means include everything in y, a, b, c, and also z. So we have b, we have c already in there. We need what, d, e, and f? Yeah. All right. Then intersection says it has to be y intersection z for number 10 says it has to be in what do they have in common? So intersection is what they have in common. So y is ABC and z is B, C, D, F. So what do we have? B is in common and C is in common. Okay. X complement or X prom means not in X. So if the universal set is A, B, C, D, E, F, G, and we know X is A, C, E, G, we want to know what's not X, but it's in the universal set. B, so B is missing, A, B, C, D, E, D, and F. So did I miss anything? Got it, okay. All right, so the next part, now we're going to do a couple of operations in one. So for 15, we're going to do the X prom. Then we're going to come over to the right and do Y prom. After we get those two sets worked out, then we'll take the intersection of them. So try not to do too much at one time. So we'll do X prom. So X prom we just calculated, so I'll copy it down. B, D, F. That's X prom. Intersection. Y prom is what's in the universe, what's not in Y. That's in the universe. So A is there, B is there, C is there, so we need D, E, F, and G. Okay, now that we have X prom and Y prom, we're now going to take the intersection of those, and intersection means what do they have in common? What's both in the first set and in the next set. So the solution of 15 will be what they have in common, and it looks like D is in common and F. So let's set with D and F. Okay. So you don't want to try to do too much at one time. We want to break these apart. On number the 17, we're gonna write this stuff. So first of all, let me have X. That's A, C, E, G. X union. Now for the first part, I'm going to go ahead and take the intersection of Y and Z. What does it mean, take the intersection? What they have in common. So let's look at what Y and Z have in common. No, they have a B and a C. Is that all? B and C. So I'm going to put B and C because this is my intersection. Now I want to take the union of it. Union means include one of everything, basically. So we're going to do A, C, E, G, and then B. The only thing is we don't have to repeat the C. So the union of these are A, B, C, E, and G. Okay. Remember, it doesn't necessarily have to be in the exact order. You just need to have it included. So sometimes I'll put them alphabetically if it's easy, if it's convenient. Sometimes I won't. So. All right, 23 is X minus Y. Set X minus set Y. So if we take X, let me get back where I can see it, A, C, E, G, and take out Y, that means the A's cancel, the C's cancel out, and what do we have left? E and G. Okay. Good. The next is just, are these always true or not always true? Um, so we're going to remember subset. So A union B. Tell me what A union B means. We included everything, right? We took A, included it, took B, included it. So it means for the statement, A is a subset of B. Will that always be true? That saying, will A be in the intersection of those two, the union of those two? Well, yes, because the union includes everything of A and everything of B. So it's saying, will A always be in that? Yes. So we would say, always true. Okay. A intersection B. The intersection says what for the right hand part of it, A intersection B. Remember, intersection is what they both have in common. So will the entire set A always be included in the intersection? No, not always. Sometimes it may be, but we can't say always, so not always true. All right. Next we'll have true false. Um, the ordered pair 3, 2 is equal to the right hand side, which this calculates to be the right hand side. What is 5 minus 2? 3. What is 1 plus 1? 2. So the question is, are they equal? Yes. They are true. Because one's just not simplified and the other one is. But the next one is what's tricky. So they want to know, is the order 2, 13 the same as 13, 2? No. So that one is false. Now, the next one is when we look at the sets, the set with the element 1, 2 and the element 3, 4, is that equal to the set on the right hand side that has the element 3, 4 and the element 1, 2? Those are equal because within the set, the elements are exactly the same. 1 is paired with 2 on the left, and 1 is paired with 2 on the right. 3 is paired with 4 on the left, 3 is paired with 4 on the right. Order doesn't matter in that because the sets are the same. The elements in the set are the same. So this is true. Cardinality. Next is we're going to do cardinality. If you're given set A and you're given set B for number 75, it wants the cardinality of the Cartesian product. So first of all, let's just do some scratch work. What's the cardinality of A? 1, 2, 3 elements. What's the cardinality of B? 1, 2 elements. So therefore, the cardinality of a Cartesian product, we would say you just multiply those two. So 3 times 2 is 6. Now 79, we kind of think backwards a little bit. They're telling us the cardinality of the Cartesian product, and they tell us the cardinality of A, and then they say find B. So what do you think we do there?
Since it's saying the cardinality of A times B is 72, and we know the cardinality of A defined in B, I would divide each.
So 72 divided by 12. That means cardinality of B must be 6. All right. Our next one, we have our universal sets given to us, A, B, C, D, E, F, G. They tell us set A, and they tell us set B. And then they say place all the elements in a Venn diagram. Place these elements in a Venn diagram. So jot them down And then we're just gonna go find where they need to be. So U is just everything. You save U for last. What you want to do is go to A, fill in all your set A. Go to B, fill in all your set B. First of all, what's going to go here? What they have in common, right? What's in both of them? A B, a D, and a G. So the one that's in both of them, you want to put those there. So B, D, and G. B, D, and G is going to be in common to both. What's in A but not in B? So I'm looking for what's left to go in A, but that's not over here that we didn't use. We already used B, D, and G. So what's left? Just F, right? So we're going to put F. And we need to know what's in B that we didn't already use. So B, D, and G is used. B, D, and G. So we have left is A and E. So we would put A and E in there. And the last thing is we need to make sure that everything has been used. So look in the universal set. We've used A, we used B, C. C is not in either one of those. So we'll put C out here somewhere. It's C is in the universe, but not in either one of these. So C, we've used D, E, F, and G. So basically C is the only thing that's out here in the universe that's not in A and B. Okay. One of the next things we have to do is use a diagram to shade each set. So I'll give you just a second to sketch that out, and then we'll look at it. Okay, let's look at the first one. I'm just going to draw a rough sketch to put my answer back over here. The first thing that I'm going to do is highlight. I recognize that I'm going to do intersection, and intersection in my mind says what they have in common. But because that's A prime and not A, first of all, I'm going to kind of get my mind set around that. So I'm going to highlight everything over here that's not A, roughly, real quick. So this is not A, right? And then I'm going to say, I want to know what's in common with that. Oh, shoot, I didn't do all of not A. Because that's not A as well, right? So everything should be yellow except for the circle A. Except for this part, okay? Now the other thing I'm gonna do is look at B. So when you say what do those two have in common, it's just gonna be the region. Let me highlight it here. It's gonna be our this part only. So that's the solution set. Sometimes it's easier to go off to the side and do scratch work, so you can see where they overlap. And the solution is just going to be the portion of B that's not touching the A, that's not sharing with A. Okay. So if I do a rough sketch here and not A. So one more time, let me try not A. That's a complement. Okay, and then B. So it's saying, what's the union of those? What's the union? So that's include everything. So basically it is going to be what my highlighted part is. So basically this time the answer is everything but this portion. So let me come over here and just kind of so moving the scratch work and just looking at the solutions, that's what we have.